Okay, rule is if we're solving a linear equation, an equation where we only have x's to the first power, which is all we're dealing with for now, right? And this works in many other instances too, but we're focusing on linear equations. I can't isolate a variable until I've got a single instance of that variable. So the rule is, can you see a single variable? If I can point to a single variable, then I can isolate it by using inverse operations, right? Going backwards through order of operations. So in this case here, I can't. I see x's here and here. So I'd have to do some simplification, right? I'd have to distribute the 3, and then I'd have to combine the x's on one side, right? By adding or subtracting some number of x's. But once I get to a point where I have a single x, then I can isolate with inverse operations. So give me 1 to 5 on that. Is that all stuff all making sense? Okay, good, good. So then the next step, and here's where I think maybe I need to talk about this today, is stuff like this. Like what if I've got an equation like that? Okay, that looks pretty ugly. What's so super ugly about that equation? I mean, when you look at that, you're probably thinking, "Oh man, that's gonna be a lot of work." And why? Let's get rid of earbuds and all that stuff, please. Don't want to see any of that. So you're looking at that. What's causing the issues? Well, you're looking at that thinking, a lot of work. How come? You got lots of fractions, right? We got a whole bunch of fractions there. So that would be a pain to be adding and subtracting and multiplying and dividing all those fractions. Common denominators, it's going to take a while. Okay, but there is a really good technique to use here to make this much easier. It's called clearing fractions. It's very useful when you have a sum of terms on both sides of the equation, which is what we have here, right? There's nothing is being multiplied here. We just have a sum of terms on both sides. How many terms are there on the left side of this equation? Show me with your fingers. How many terms are on the left side? Yeah, it's 2, isn't it? Right? It's 2 because I've got two things that are being added or subtracted. I've got the 5/8 x is a term and 3/5 is a term, and I'm subtracting those. How many terms are on the right side of the equation? 2. Good, 2 terms. Nothing's being multiplied. I'm just adding terms on both sides, adding or subtracting terms on both sides. So this is a prime candidate for clearing fractions. Now, the way we clear the fractions, step 1 is we have to find the least common multiple of all the denominators, which is the same thing as the least common denominator of all the denominators, right? Now, what is it? What is the least common multiple of all the denominators? Or in other words, the least common denominator? 40. Yeah, how'd you get that so quick? Okay, yeah. So 8 times 5 is 40, and then you can see that's a number they all divide into. Because fundamentally, isn't that what the least common multiple, what a least common multiple is? It's the smallest number that a bunch of numbers will divide evenly into, right? And that's all the least common denominator is. So we want the smallest number that 8 and 5 and 4 and 20 will all divide into, right? So how do we find that? Well, you guys are just smart. So a lot of times it's number sense just kicks in and you get it. But what if these were really big numbers, really ugly numbers? There is a little bit of technique here. I want you to notice something. If we look at the list of multiples of each of those different denominators, they're the multiples of 20, multiples of 8, multiples of 4, and multiples of 5. Well, the least common multiple, least means smallest, and common means shared, right? So what's the first number on those lists of multiples that is shared on the list? Well, it's 40, right? We already established that's 40. Okay, and here's 40, there's 40, there's 40, and there's 40. Which list would probably be easiest to use to find that common multiple? The 20 is, yeah. There's only, how come? Because they're big chunks, right? They're big steps. I don't have to go very far along that list of multiples until I find the least common multiple of 40. So as a general rule, when you're looking for a least common multiple, you always want to start with the biggest number and look at multiples of that until that the other numbers all divide evenly into. Does that make sense? Okay. All right. So in this case, it's 40. All right. What are we going to do with that 40? Okay, well, we're going to multiply it through. We're going to distribute it through both sides. The nice thing about this is we don't have to mess with any of these common denominators. We don't have to get 40 on the bottom of each fraction. We just have to know what the common denominator would be and then distribute that through the whole equation. Okay, now look what happens when we do that. It's almost like magic. Can anybody tell me why this is such a good trick? Like what's going to happen with the 40 here, just real briefly? Can you see something really good going to happen when I distribute that through? All the fractions will end up being whole numbers. Yeah, well, integers. They might be negative, right? But they'll be integers, won't they? Okay, and how come? Think about this. Now, when we multiply fractions straight across, we just, we could, like for example, when I distribute the 40 to the first term, I could multiply straight across and get 20 over 8. Okay, and 20 over 8 is going to reduce to an integer, but that's a pretty big fraction to reduce, right? Instead of just multiplying straight across like we normally would, multiplying straight across and then reducing a big fraction, let's take advantage of the fact that this 40 is a hand-picked number. We picked the 40 precisely because all of the denominators divide into it evenly, right? So we know we're going to be able to reduce these fractions. Let's do that before we multiply, right? So when I distribute the 40 over 1 to the 5 over 8, let's first ask ourselves, what does 40 over 8 reduce to? 5. And then that's what we multiply by the numerator, right? When we're clearing fractions, that trick is always guaranteed to work because we know that the denominators are going to divide into the least common multiple evenly every time, right? So 5 times 5 gives us 25 and then an x, right? Same thing here. Instead of multiplying straight across, 5 or 40 over 5 reduces to 8 times the numerator gives us minus 24. Question? Cross, say, like, give me like from this one right here. What would I do?
So like take the denominator of the 3 over 5 and then multiply it by the numerator of the 5 over 8. And you would still get the same answer. That's just how I learned it.
I'm not following. Like what?
You did 5 times 5 is 25 and 8 times 3 is 24.
Oh, no, you can't. You can't cross multiply here because it's not a proportion, right? It's different. When you cross multiply, I know what you're saying, but no, that's not going to work here. Like if we had something like this, like if I had 5/8 x equals 3/5, then you would cross multiply because I've got a single fraction equal to a single fraction, okay? And we'd get 25x equals 24, and then we'd solve for x that way, okay? Is that what you're saying? I can't do that here, though, because I've got all these other terms that are being added, right? When you cross multiply, what are you really doing when you cross multiply, like in a situation like this? What I'm actually doing when I cross multiply is I'm multiplying each side by 5 to cancel that denominator, and I'm multiplying each side by 8 to cancel that denominator, right? You get that? Like if I were to, the next step would be if I distribute, I'll show you what I mean. If I distribute a 5 all the way through this, I can just put that x up in the numerator with the 5, couldn't I? Right? So 5x over 8 equals 3/5. Well, what's going to happen? When I distribute that 5, I'm going to get 25x over 8 equals 5 times 3/5 is just 3. So then I'm going to multiply each side through by 8, distribute that all the way through. And what happens here when I distribute the 8 times 25 eighths just gives me 25, right? The 8's cancel, so I get 25x. On this side, I get 24. So you're really doing the same process. When you cross multiply, you actually are clearing the fractions. But because you only have one fraction on each side, you can do it much more easily by just multiplying across the equal sign. But it only works, cross multiplying only works when you have a single fraction equal to a single fraction. Okay? All right, so continuing on with our stuff over here then. So very good question though. So if I distribute the 40 over 1 to the other side of the equation, which we must do. 40 over 4 reduces to 10. Times 3x is 30x, right? And then plus, here, you know what? I better. Hey, Kim, what's up? Uh-huh. Uh-huh. It is. Oh, I know what happened. I know what happened. Yeah, I know what happened. Um, maybe. Let me. I think it's you can. Yeah, you can. You can. And I think what happened was I didn't think about that. I couldn't figure out how students had gotten into that. It's because you had assigned it. So I think I messed it up. But I won't do that anymore. Now I know it. Now I know to expect it. No, but when I go into the coordinator class and I try to make some edits to it, if your students have already tried it, I can't edit that, which is okay. It's not the end of the world. Yeah, yeah. It's yeah, but it kind of it messes up the coordinator classes, but it's okay. Don't worry about it. It'll still work. But you're gonna probably have to just rename that again. Mm, I don't know. I don't know. It seems like it ought to still be there, but if you're saying it's not, they might have lost a little bit of it then. Yeah, I would think it'd still be there personally, but does it show up at the bottom? Way down at the bottom? Okay. Yeah, I think I did that. Yeah. But no, no, it won't. I just won't ever delete them anymore. Yeah. 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 Just try it again. Yeah. But then it should work. No, they won't get it back. I deleted it. It's gone. Yeah. Yeah. Tell them I'm sorry. There you go. Yeah. All righty. Okay. Bye. All right. Sorry about that. Okay. So then last step. So 40 over 20 reduces to 2. There you go. Times 17. Did you? All right. But now, and we won't even go any further, but we don't need to, right? That's easy now. Look at the beauty of that. We eliminated all the fractions. And so now it's a piece of cake, right? Now all I've got to do, where am I going to push the x's on this problem? Left or right? I'm going to go to the right because I want a positive coefficient of x, right? So I would just subtract 25x from both sides. So those guys cancel. And then look what I get. Negative 24 equals 5x plus 34. Now I just isolate x. What would the steps be in order to? Yeah, question. How the first part? You mean this part right here? Okay, this is the same thing. Here's how that works. Like if I were going to take this here, let me go. I think I got another one of these on the next page. Okay, here's why. Because like if we were to, I'll show you the long way. You're okay with the idea that you have to multiply a 40 through? Right, you're going to multiply through the least, and what am I doing? It's okay to do because I'm treating both sides of the equation equally. I'm multiplying both sides by the same thing, right? So technically what I'm doing is I'm really doing this. I'm multiplying 40 times the left side and 40 times the right side. It's just a little bit easier to show it this way, even though this isn't really technically a valid thing to do, to put a 40 out in front of a whole equation. But really, it's implied what we're doing. We're just distributing it all the way through, okay? So we've got this 40. We could think of it as 40 over 1. Now, if I were to directly distribute that to all the terms, watch what happens. 40 over 1 times 5 over 8 is going to give us 200 over 8x, right? Minus, if I multiply here, I'm going to get 120 over 5 equals a bunch of stuff on this side. Now I've got to reduce the fractions, right? Well, what am I going to get when I reduce those fractions? 8 goes into 200. How many times? 25 times, right? So that's going to reduce to 25x. 120 over 5 is what? Is 24, right? Okay, well, where did we see that before? We saw that right there, right? Okay, you see, but we did it in a smarter way here. It's easier rather than multiply first and then divide. Why not divide those fractions out first to reduce them and then multiply? Okay, does that make sense? Okay, okay. Now, does this always work? The answer is yes, it always works when you're clearing fractions. If I had just given you some random problem that wasn't a clearing fractions problem, what if the number out front had just been arbitrarily like 60 or something? Is it going to work then? No, because 60 wasn't a hand-picked number that all of the denominators divided into evenly, right? You really should only reduce first and then multiply when you're clearing fractions, when you know it's always going to work. Okay, does that make sense? Okay. All right, and then again, from there on out, it's a piece of cake. What would the last two steps be to isolate x? What would I do first? Subtract 34 and then divide by 5. Okay, make sense? All right, so we've got the clearing fractions. Do you want to try one, or would you rather just do it on your homework? I don't care. I mean, for you guys, I don't think maybe it's better just try it on your homework, and if you have questions, come see me. We'll get. I don't want to waste time for you guys. I mean, you pick this stuff up really fast. Okay, there's one thing I do want to point out though. This is a slightly different example. What's different about this one? Okay, I'm multiplying, right? So in this case, we have to be careful because this time we don't just have a sum of terms on both sides, right? I'm multiplying this 1/2 times the sum of terms. You get what I'm saying? So you can't just go through and immediately clear fractions. You have to be a little bit careful. So what do you probably have to do first? Good, you have to distribute the 1/2 through. Now you might be thinking, okay, Mr. Roy, you're lying to us. You told us we weren't going to have to deal with fractions, and it was a little white lie. You have to in this case, but what's easier to do, multiply fractions or add or subtract fractions? What's easier? Multiplying by a mile, right? Multiplying fractions is way easier than adding or subtracting fractions because you don't need a common denominator. You just multiply straight across. So distributing the 1/2 honestly is no big deal at all, right? We just distribute the 1/2 to both of the terms on the left side. What's 1/2 times 7/8? 7/16, isn't it? We just multiply 1 times 7 is 7 on the top, 2 times 8 is 16 on the bottom. So I get 7/16 x. 1/2 times 3/4 is what? 3/8. Everybody agree? Minus 3/8 equals 13/10 x minus 1/2. And now look, now we're back to an equation that is a sum of terms on both sides, and now we could just clear fractions. Okay, is that good? All right, then I'm going to let you work. I want to let you jump into this assignment, get some work done. We'll come back to this stuff tomorrow.